Welcome back to this lecture series on deep learning. In this lecture, we'll learn what is hyperparameters and what is validation test, how it will be used for developing the deep learning models. We'll see one by one. First, what are hyperparameters? The hyperparameters or external settings chosen before training a machine learning model. That means hyperparameters are configuration options that are set manually before the learning process begins. These are not derived from data but are defined by the developer or researcher to control how the training process unfolds. Next, these values control how the model learns but are not updated during training. That means, unlike model parameters, what are all the model parameters? Usually, we are considering weights. See one way. So the model parameters always we are considering it as the weights. So here, unlike the model parameters means weights which are learned from the data. Weights means which are always learned from the data. It is not like that. Not like the that is learned data. Hyperparameters remain fixed throughout the training. This hyperparameters throughout the trainings we are going to fix it. They influence training behavior such as so this hyperparameters influence the training behavior. What are all the training behavior means? Learning speed, model complexity, one by one. Model complexity and optimization strategy, but are not modified during the model's learning parameter as like weight. And if you are taking the example, the learning rate is the several hyperparameters are commonly used in machine learning, and choosing them appropriately can significantly affect model performance. That means if you are taking the learning rate 0.01, the learning rate what it determines the size of step the size of the steps the model takes, how many steps it takes, size of the steps the model takes when updating, when update size of the steps the model takes when updating the weights. This is what the learning rate says. For instance, a learning rate, we have taken it as 0.01, means the model adjusts its parameter moderately. In this case, it will adjust the parameter moderately. If the rate is too high, this value is too high, what will happen means the learning rate is too high means the model might overshoot the optimal value. Overshoot. And if the value is too low, the learning could be very slow or get stuck. This value is too low means the model may be stuck at some point. This is the drawback if you are increasing this value or completely decreasing the value. If you are taking this 0.1, it will give us the moderate parameter adjustments. Next, batch size. Here we have taken it as 32. Say for example, batch size refers to the number of samples processed before the model's weights are updated. Before the model weights are updated, that is smaller batch size tend to generalize better. Smaller means model generalize the better but train slower, while larger one are computationally efficient. But what is the drawback of the larger batch sizes? It may miss fine grained updates. This is the drawback of if you are increasing the batch size or decreasing the smaller batch size tend to generalize better but trains slower, and larger batch size if you are taking it computationally efficient but may miss fine grained updates. Next, epoch 50. Here we have taken for the example, an epoch defines one full pass through the entire training set. The training for 50 epoch means the model sees the entire training data how many times? 50 times. Too few epochs may lead to underfitting, and too many could lead overfitting. Two, that is a smaller epoch, it will leads to underfitting, and over epochs values are high, it may lead to the overfitting. So this value also we have to fix it a moderate value. Next, number of hidden layers. If I am taking 3, if you are taking the number of hidden layers are 3, the number of hidden layers, what it will do, it will determine the depth of the neural network. Hidden layer means it will determine the depth of the neural network. NN means neural network. A model with a 3 hidden layer is moderately deep and can capture complex data patterns. However, more layers if you are going, it will increase the training time and risk overfitting if not regularized properly. So this is main drawback. Next, and these settings are tuned to improve performance and accuracy by adjusting hyperparameters. By adjusting the hyperparameters, one can influence how well the model fits the data, how fast it converges, and how well it generalizes. Careful tuning can result in high accuracy and more robust models, especially in complex tasks. Next, role of hyperparameters in training. The hyperparameters influence model speed, that is stability, and generalization. That means the right combination of hyperparameters ensures that the model trains efficiently, converges to a good solution, and generalizes well to unseen data. They affect not just the final accuracy but also the time and resources required for training. Next, the poor choices can cause or total causes choosing the inappropriate values for hyperparameters can result in suboptimal model behavior, such as either underfitting or overfitting. Underfitting means what? It is too simple model. If the model is too simple or if the hyperparameters are too restrictive, like too few layers or too low epochs, what will happen? It may fail to capture important patterns in the data, learning to poor performance on both the training and testing. Next to overfitting means it will memorize the training data, all you know that. On the other hand, if the model is too complex or trained too long without proper regularization, it might memorize the training data instead of learning general parameters, which lead to poor validation and test performance. And if you are taking the example, particular illustrations of poor or good hyperparameter choices help in understanding the impact. A high learning rate, if you are taking the high learning rate, what will happen? It may skip the optimal solution. If the training rate is set to too high, that is zero point 0.5, say for example zero point 0.5 like that, the model might jump over the optimal value during training, leading to unstable updates and poor convergence. It will not be stabilized. And lower training rate, if you are considering lower learning rate, may take too long. It will take too long to convergence. Conversely, very small learning rate, if I am taking very small learning rate like 0.0001 like this, can slow down training significantly and may stuck in local minima. This may be stuck at local. This is main drawback if you are going for low value, stuck at the local minima. So we should not choose over high value or low value. It may lead to some problems in this. So requiring excessive epochs to reach the good performances. If you are taking too low, the value of learning rate is too low, it will take lot of epochs to reach the good performance. Next, proper tuning is essential for balance and performance. How means balance speed. Balancing the speed and accuracy through hyperparameter tuning is important. Efficient training and good generalizations are only possible when parameters are adjusted to match the complexity of the data and model. Next, what is validation test? Validation test is a first validation is set as a separate part of the data set not used for training. It is a separate part of the data set. That means a validation set is created by splitting the data set into, if you are taking the bulk data set, if we are going to split into portions, partially portions we are going to consider. Unlike the training set, it is not used to update the model weights but serves to monitor the model's progress during training. Next, it is used to check how well the model performs unseen during training. As the model trains on one portion of the data, the validation set provides a way to evaluate how well it is likely to perform on data it has not seen before. This gives an early indication generalization. If you are taking the example, let us consider how the data set is typically split. In a data set of 10,000 samples, we are going to consider a typical division of training a deep learning model is allocate a majority of data for training. Majority of data we are going to take it for the training. We have to train the model and reserve a part of the validation and testing. So 70 percentage. So out of 10,000, 70 percentage means how many? 7,000. 7,000 we are going to use it for training. This part is used to train the model by updating the, so training means what? Updating weights, updating weights and learning features. Learning features. That is known as training. And we are going to take only 15 percentage. 15 percentage means how much? 1500. We are using it for that is validation used during training to fine tune the hyperparameters. Fine tune the hyperparameters and make decisions like early stopping. Next, the 15 percentage we are going to take it for testing. It is used at a very end to evaluate the final performance of the selected model, and it helps avoid biased performance estimate. Using a validation set ensures that model tuning does not bias. So it will avoid the bias, does not bias performance measurements. This makes the final model selection more reliable and avoids it avoids this case avoids overestimating overestimating accuracy. Very, very important point. Next, purpose of validation set. It is used to monitor the model's generalization ability. Validation data set acts as the indicator. That means this will act as the indicator of how well the model is learning generalization patterns. If the model performs well on validation, it's more likely to do well on unseen test data, that is test data too. Next, helps in selecting the best hyperparameter settings when experimenting with the different hyperparameters like batch size or number of batch size or batch size number of epochs. If you are considering number of epochs, the validation sets helps choose the configuration that yields the best validation performance. Next, it prevents overfitting by acting as an early warning. That means if validation accuracy begins to decline while training accuracy continues to rise, it signals overfitting. The training can then be stopped or regularization increased to preserve generalization. And say for the example, if you are taking the example, an illustrator example helps understand its practical importance. If accuracy on training data is 95 percentage, but on validation only 70 percentage, the model is likely overfitting. Such a large gap suggests the how much percentage 95 minus 70. So approximately 25 percentage. This is a large gap. Such large gaps suggest the model is memorizing the training data and falling into generalized. Validation performance thus acts as a checkpoint to detect and prevent this problem. Next, hyperparameter tuning using validation set. Train the model with various hyperparameter settings. We have to train. To find the optimal settings, several models are trained using different values of learning rate, batch size, number of layers, etc. This process helps identify which combination performs best, either learning rate or batch size or number of layers. Next, evaluate each on the same validation set. This means each model configuration is evaluated on the same validation dataset to ensure a fair comparison. Thus, uniform testing helps pinpoint the most promising model setup. Next, select the configuration that gives the highest validation accuracy. After evaluating the configuration that yields the highest accuracy or lowest error on the validation set is chosen. This is assumed to generalize well to unseen data. And example, let's consider tuning rate, that is learning rate as, let us consider tuning learning rate as 0. That is we will consider three learning rates: 0. 0.01, 0. 0.001, 0. 0.0001. Each model is trained separately with one of these rates. So here three models we are going to take, each will be separately trained. If the validation, so choose the one that gives the best validation accuracy, 0. We are going to choose it 0.001. If 0.001 performs best validation, that configuration is selected. Final model is tested on the test set after tuning. Once the model once the that is a final model is tested on the test set after tuning. Once the model with the best validation performance is finalized, it is evaluated on the test set to measure true generalization ability. This test accuracy gives the most honest estimate of real world performance. Next, coming into the summary, with example, hyperparameters guide the learning process. That means learning rate and batch size. They define how the model is trained, controlling learning speed, depth, and other behaviors. Without proper hyperparameters, even a powerful model may perform poor. Next, validation set is used to tune those hyperparameters and select the best model. It provides feedback during the, so the what will happen means it will provide the feedback during training to decide which hyperparameter settings yield the best results. It acts like a rehearsal before the final model is tested. So next full example, if you are considering, combining all the concepts helps solidify understanding. Data splits is 70 percentage for training, 50 percentage for validation, and 15 percentage for testing. This common splits ensures enough data for learning while maintaining reliable tuning and evaluation. Next, tried 5 learning rates. Best on validation, we can take, so any 5, so we'll be taking 0.001. If it is giving a better performance, we'll consider. Multiple learning rates were tested and 0.01 gave the best validation accuracy. Trained final model with that, then tested on the test set. After selecting the best configuration using validation, the model was retrained and tested on the untouched dataset for final evaluation. So together they improve model robustness and accuracy. How means using well-chosen hyperparameters and a validation set ensures that model not only fit the data well but also generalizes effectively, making it reliable for deployment. And coming into the conclusion, the hyperparameters are essential setting that it defines how model learns and must be carefully chosen before training. Next, the validation sets plays an important role in assessing the model performance during training without influencing the learning process. And hyperparameter tuning using validation data ensures the model achieves the right balance between underfitting and both are unwanted. So we have to use the moderate values. If you are going, the learning rate is too low, it will go into the underfitting, otherwise it will go into overfitting. So both are not required or not wanted, so we have to moderately tune the settings. Next, together hyperparameter tuning and validation helps create a robust and accurate model which will be suitable for real world data. Hope everyone understood about what is hyperparameter and what is validation set, how it is important to tune the networks. The remaining things we'll discuss in the next lecture. Thank you.